In this third video, we are going to see how to add sounds and collision detection to our video game. Let's start with the sounds. In a video game, there can be two main types of sounds. We can talk about background music and about sound effects. To manage all these kind of sounds, we need to use two different classes in our JavaFX project. First of all, we need to use a media class to store every media file that we want to play in a given moment. And also, we use an additional class called media player, which is in charge of playing every sound file. If we need to play more than one sound file at the same time, then we need to use more than one media player object. In other words, we need a media player object for every sound file that needs to be played simultaneously. So with these two objects, media player along with media, we are going to be able to play both background music or sound effects. First of all, in our parent abstract class called general scene, we are going to add both a media player attribute along with a media attribute. We need to import the corresponding classes from the appropriate packages, which is javafx.scene.media. Next, we are going to include both audio files that we are going to use in our video game. You can download them from a zip file that you can find below this video, and then we just drag and drop the audio files inside our assets subfolder. You can either copy and paste the files inside this folder if you want to, and then we have these two audio files inside our assets subfolder. Now we move to game scene class, and we are going to start playing a background music which is contained in this file autumnleaves.wav. Okay, so we use a constant to refer to this file, okay, and then in our draw method we are going to initialize both media player and media object to refer to this sound file and start playing it. Then in our draw method we load the corresponding background sound from this audio file inside our sound object, which is a media object that we are inheriting from parent class, and then we initialize the media player to play to be associated with this sound and play it. In order to play it indefinitely, we need to set a given property from media player, which is this property set cycle count, to indefinite value. So as the song finishes, this media player can play it again and again in an eternal loop. Okay. So if we try to run the game right now, we can get an exception. Okay, as soon as we move to the game scene, we can find an exception in our console. We press the spacebar key, and then we see this exception in the console. The problem is that we need to access some media managers that are not visible by default. In order to fix this, we need to add a special configuration file in our project inside source folder. We right click on source folder and choose new module info java file. This special file tells Java which packages need to be visible from a given project. So inside this file, this configuration file, we need to indicate which packages we need to access from JavaFX. To be more precise, we need to require two packages from JavaFX, which are graphics and media packages, and we need to open our main package video game where our main class is being located, so we can run this class and use these packages from JavaFX in order to reproduce our media files, our sound files. Okay, if we rebuild the project now, we go to build menu and choose rebuild project. We make sure that everything is updated, and when our build process has been completed successfully, we can see it below, we can run the game and see how our sound is being played. Okay, so we have our background music in the game scene, and as soon as the music finishes, he's going to be replayed again. This is the moment where the music is going to be played again. Okay, so now we are going to add a second sound in our game, but we are going to use it later. This is the a sound effect that is going to be played whenever our bird catches a fruit. But before we add this sound effect, we need to catch the fruit. Okay, so let's go with collision detection. Regarding collision detection, we need to talk about different types of collision. On one hand, we are going to deal with collision detection referring to the main character and the scene boundaries, so that the bear can go over the scene boundaries and lose the image from the left or from the right of the scene. Besides, we need to check collision detection between the bear and the fruits that are going to fall from the sky. So let's start with the collision detection with scene boundaries, which are easier, and then we add some fruits to our scene and add the collision detection between the bear, the main character, and these fruits. To achieve this detection, we just need to edit our main character class, go to move method, and replace this if-else statement with this new one, in which we are moving to left or right just if our current coordinates lets us move to this direction. If you pay attention to this code, we decrease the x-coordinate only if our x-coordinate is positive. As soon as it's 0, we no longer decrease this coordinate, so we can go beyond the left limit of our scene. Regarding the right limit, we do the same, but taking into account the game width and the character width to subtract this width from the right side. If we check this, we can see that the bear stops as soon as he reaches the left edge, and if we move to the right, also the bear stops at this edge. So we can even play or change some parameters in these two checkings. For instance, if we need the bear to move a little beyond these limits, we can, for instance, decrease this restriction according to character width, and then the bear can go beyond the right limit just a little bit. Okay, so we can use these two rules and tune them to our preferred requirements. Okay, now we are going to add an additional sprite to our video game to represent the different fruits that are going to fall from the sky. This can be our new sprite class, which is a subtype of sprite parent class. We refer to fruits image inside our assets subfolder, and then we are going to deal, for instance, with two different types of fruits. So we use a constant to define the maximum number of different fruits that we are going to manage. Every fruit that we are going to take into account has the same width and height of 30 pixels. In this case, we are going to use two different constructors. An empty constructor, which is going to generate a random fruit among all our available fruits, in this case our two different fruits. If you take a look at the fruit image, there are 5 different fruits. In our case, we are going to use only strawberries and bananas, but we can also use any other fruit of this image following the same pattern that we are going to see next. So this empty constructor is going to generate either a banana or a strawberry depending on the random number that it's going to be generated. It can be 0 or 1. In this second constructor, we are going to generate a given type of fruit, either a banana or a strawberry. We call supper constructor to set the width and height of this sprite, and then we load the sprite image with every fruit that we can need. Depending on the parameter, the integer parameter, if it's 0, we are going to use a banana, which is located at these coordinates in the image sprite. And if we generate a number 1, or if we use number 1, then we are going to use or generate a strawberry, which is located at these coordinates in the sprite image. So we are going to use this empty constructor to generate a different or random fruit every time that we need. Regarding the move method that we have here, we just increase the vertical coordinate, the y coordinate, to make the fruit move down from the sky to the floor. In the game scene, we add a new attribute, which is going to be every fruit falling from the sky. We need to import the corresponding class. Then at the end of our animation timer in the game scene, we can check if fruit object is null. Then we instantiate a new random fruit and place it at a random position at the top of the scene, a random position between 0 and the game width. Okay, and if fruit is not null, we move them down. We call its own move method to increase its vertical coordinate, and as soon as the fruit reaches the bottom of the scene, we remove them. We remove the fruit, we set it to null again to instantiate a new fruit at the beginning of the scene. Finally, we need to draw the fruit in every loop of our animation timer. We can draw it in the same place that we are drawing the background and the bear. Remember to draw the fruit after drawing the background image, otherwise the fruit will be hidden behind this background. Okay, if fruit is not null, we can draw it using the same graphics context that we are using to draw the bear. If we play the game now, we can see how fruits are going to fall from the sky. This is our first fruit, and as soon as this fruit reaches the bottom of the scene and disappears, then a new fruit is going to be generated randomly at the top of the scene in a random x coordinate and using a random fruit. It can be either a strawberry or a banana. However, our bear still can't catch the fruits falling from the sky. We need to implement a simple collision detection algorithm to let our bear catch the fruits. To implement this collision detection algorithm, we are going to assume that every sprite in our video game, every image that needs to have collision detection, is represented by a rectangle or box around this image, around this sprite. So we can assume that there is one sprite located at coordinates x1 and y1 with a given width and a given height. And we have also another sprite located at different coordinates x2 and y2 with its own width and height as well. So we can say that these sprites are going to collide if and only if there is a shared area between their corresponding boxes. If the box of first sprite shares a common area with the box of the second sprite, then there is a collision between these two sprites. Let's see how to implement this collision detection in our video game. We just need to go to our parent sprite class and add this method in this file. This method collides with method checks if our current sprite, this object, collides with the sprite passed as a parameter, sprite sp. We just check with these multiple conditions if x and y coordinates of one of the sprites are more or less in between of the other sprite. So we are going to simplify the algorithm seen in previous slide. Now we open our game scene class, we move to our animation timer loop, and when we check if fruit is falling down, okay, if fruit is null, then we instantiate a new fruit, that's okay. But if not, if fruit is moving, we need to check if fruit and bear are colliding. We can check if fruit collides with bear. If this is true, then we can set the fruit to null. And otherwise, we can keep checking if the fruit reaches the bottom of the scene to set it to null as well. Okay, so if our bear collides with the fruit, we catch it and generate a new fruit from the top of the scene, at the top of the scene, sorry. And if fruit goes down to the floor and disappears, then we also generate a new fruit. So let's play again. And now we will see how our bear can catch the fruits falling from the sky. We place the bear below the fruit and then we catch the corresponding fruit. So the fruit is reloaded every time our bear catches it or every time it falls down the scene. Okay? Now we are going to add a sound effect to be played every time our bear catches a given fruit. As we said before, we need an additional media player object to play this additional sound because the main media player is being used to play the background music. Okay, so we are going to add an additional media player along with its corresponding media object inside our game scene to play sound effects. These are our two new media player and media objects that are going to be used to play sound effects, and then we are going to add a new additional method to play these sound effects. This can be the new method, a private method that can be placed at the end of our source code in game scene class, and we just passed a path as a parameter referring to an audio file in our assets folder, and then we load this audio file inside our media object. Okay, then we instantiate our media player and associate it with the media object and play this sound effect. So we can call this method every time we need to play a given effect. For instance, every time our bird catches a fruit, we can play an effect referring to this sound effect, quick jump audio file. We are going to add this audio file inside a constant here. This audio file is quick jump. And then we play this sound effect from this point. Okay, so every time our bird catches the fruit, we are going to play this sound effect using our secondary or additional media player and media objects. Now we can run the game and see how this works. We place the bird below the falling fruit, and this is the sound that we can listen. Okay, this sound is going to be played every time our bird catches the fruit. So we have learned how to add different sound files and music and sound effects to our video game, and we have also learned how to check some basic collisions in our video game, referring to scene boundaries so that we can make sure that our main character is not going to move beyond the scene limits, and more important, collisions between our main character or any other sprite in the video game. For instance, with objects, fruits, enemies, we can use this simple method, collides with, to check if any sprite of the video game collides with any other sprite. We can apply this method to many different scopes in our video game. In next video, we are going to learn how to increase the difficulty of our video game and show the current state of our main character, referring to the score and the health or number of lives pending.